begin to go over the open book test for Unit 1-5 of Calculus. It says complete the table and then tell whether the function f of x approaches infinity or negative infinity as x approaches negative 3 from the left or from the right. So, when we look at this function, we realize that we have a problem because this would factor into 3 over x plus 3 times what? X minus 3, because we have the difference between two squares, which factors into those binomial conjugates. That means that x cannot be negative 3 and x cannot be 3. I should put and. So those are the exclusions, and we also know, because there's factoring opportunity, that there would be vertical asymptotes in the graph at those places, right? Now, what we want to do, we realize that as x approaches negative 3, then we're approaching an asymptote. And as x approaches positive 3, we're approaching an asymptote. And our question is, as we're approaching the negative 3, is it going into negative infinity or is it going into positive infinity? That's the question. What is happening as the function value approaches that asymptote of negative 3? Now, because this may not be the great visual of that, I'm going to erase that. We'll take a look at the graph later. Let's go ahead and do it graphically, and then we're going to build our table. And we're just going to do this on the calculator, okay? Let's do it logically first, though. Let's do it logically first. If we're approaching from the left, that would be from the negative side, then let's think about what types of numbers would be in here. What would be in there if we're approaching negative 3 from the left? Things like negative 3.9, negative 3.8, negative 3.7, that kind of stuff, right? Now, if we square those numbers and subtract 9, we're going to have, as we square those numbers, something bigger than 9 minus 9, and then something even smaller minus 9, something smaller minus 9. So my answers as I approach are getting smaller, smaller, smaller. If they're getting smaller, 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 this is going to be getting bigger, bigger, bigger. Which means, just looking at it logically, from the left, we would be approaching positive infinity. Okay? As we thought about it from the right, if we look logically, so logically we're trying to think this out and we're thinking positive infinity. We'll verify with everything. And then we're thinking, okay, if I approach it from the right, the negative 3, then I'm going to be at like negative 2.9 and negative 2.8 and negative 2.1, things like that. And if I'm doing that, then my numbers that I'm squaring are going to be less than 9, which means I'm going to have a negative answer on the bottom. And I've got a positive answer on the top. And my numbers are still getting smaller, so that the answer on top is still getting bigger. But because I've got different signs, then when I divide, my answer would be negative. So as I approach it from the right, then it seems that we would be going into negative infinity. Okay? So we can logically try to think our way through it mathematically. Let's build a table and try to verify those ideas. So what we'll do is go to our graphing calculator. I'm going to clear mine out. We'll go second, plus 7, 1, 2, enter, clear. We're going to go to y equal, and we're going to put in our equation. We had 3 divide open x squared minus 9. That's all correct? Is that correct? Now, I'm just going to hit graph to start with and take a look. And you can see that the graph verifies that as I approach that asymptote from the left, it's going into positive infinity. And as I approach that asymptote from the right, it's going into negative infinity. So my graph verified my fraction work in my head. We can build a table then. We'll go to second graph, which is table. And when we do, we're not going to get numbers that look very pretty to us. We're not getting the numbers that they ask for. You can see, though, and I wanted to show you this, that at 3 there's an error. So there's where that first asymptote was. And if we go up to that negative 3, we can see that there was an error. We can kind of see, though, even without the numbers in our table, that as we approach from the left, the numbers are getting bigger, 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 but they're positive, so there's our positive infinity. And as we approach the negative 3 from the right, our numbers are getting bigger. Absolute value would be getting bigger, 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 but they're negative, so there's our negative infinity. So we verified it in a table that's not the table they asked for. Now, to build the table they asked for, what could we do with the calculator? We could go to Stat. Good. We want to edit, so we hit Enter. In L1, we're going to put those values that they asked for. I could pull those back up maybe and see those. Or y'all can just tell me. I'm already nearly there. I was going to see if I could make this work. And then pull my calculator back up if it won't minimize that. There we go. We should be able to do it where we can see both. So, but now I still can't see the bottom anyway. So y'all can tell them to me. They are, and then we're going to continue because that second table is just a continuation of the first. My paper wasn't long enough. So let's just keep going with the positive infinity part. And I was showing you both, but I wanted to. Gotcha. All right. All right. All right. Okay, so we just will get it all done at one time here. Now, remember what we do now? I need to hit enter. Remember what we do now? We are to the right and up to the top to put in the formula. Now, my formula was 3 divide open. It was x squared, but I don't put an x here, do I? What do I put? L1, so second one for my x values were an L1 square, and then minus 9 close. Now, I could have put that in quotes, correct, and it would have locked that formula in. Remember that? So then we hit enter, and we have those values. So we can move those values into our table now. This is where it would be handy to see both. So negative 3.5 was 0.92308. 0.92308. May be a little tough to get all these. The negative 3.1 is 4.918. Look at how much bigger it got all of a sudden. I'm going to erase that mark so it doesn't look like a negative. And then at negative 3.01, we're already at 49.917. We're getting a better picture of infinity with these numbers we chose than when we looked at the regular table. With the next one, we're at 499.92. So we can see that as we approach negative 3 from the left, from the negative side of the x-axis, moving towards the positive side, that it's going into positive infinity. So we verified what we did with our fraction work in our head, and we verified what we saw on the graph. When we look at the negative 2.99999, or whatever that was, we have negative 500.1. As we move away from the negative 3, we see that the numbers are getting smaller. I should have probably done those backwards. 08. And then negative 2.99, or negative 2.9 was negative 5.085. And then the negative 2.5 was what? I can't see it there. Negative 1.091. Okay, thank you. So as we approach the negative 3 from the right, from the positive side towards the negative side, we're approaching negative infinity. Now, the limit as x approaches 3 does not exist, correct? Because as you approach negative 3 from left and right, it's approaching something different, but it's also going into infinity, so it breaks some rules of limits. We will talk about the limit from the left, and we'll talk about the limit from the right, but we would say the limit itself does not exist at negative 3. There's a vertical asymptote, which is a discontinuity at negative 3 that is a removable discontinuity. It's a non-removable, discontinuity, which gave us an asymptote there. Any questions on number 1? Okay. I can bring those answers back for just a moment. Okay. Number 2, the directions say find the vertical asymptotes, if any, of the graph of the function. Now, how are we going to find a vertical asymptote? When there is a division by 0 error, and we can't remove the thing that's causing that division by 0 error, right? So what would cause a division by 0 error here? Well, so the denominator x squared cannot be 0, right? Well, what would make it 0? Well, if we took the square root of both sides, we would have x cannot be plus or minus 0. So we know that x equal 0 is a non-removable discontinuity. We also know that there is a vertical asymptote there. Okay? Any questions on that? So there was a discontinuity at 0. It's non-removable. We can't factor it away. We can't create a g function that's equivalent to that f function in all points but 1 that will make it go away. So it's a non-removable discontinuity, and we know that there's a vertical asymptote at x equals 0. Remember, the equation x equals 0 is the equation of a vertical line. Any questions on number 2? Do you realize in the back of our mind we've been talking about slope a lot? Remember the tangent line problem and some of that. And so limit has the idea when we look at that of slope, and we know the slope of a vertical line is undefined. So uh, there's some ideas in there that are working together for us. Okay. Well, number 3, we need to see what would cause a discontinuity. And what would cause a discontinuity are things in the denominator that would create a 0. Now, if we want to find the zeros, then we would find the factors. And we know that if your a is equal to 1 in a quadratic, then we can go straight into the parentheses without using the AC method of factoring or the quadratic formula or whatever to find the roots and then go back to the factors. And then you think, remember what you think, what do I multiply to get my C value of -2 and add to get my B value of -1. So what can I multiply to get -2 but add to get -1? So a -2 and a +1. -2 times +1 is -2. -2 plus +1 is -1. So I just stick those straight in there, right? That's how you factor if a is 1, and you don't have to go through the whole AC method. Okay, so that tells me then that there is a discontinuity at x is equal to 2, and there's a discontinuity at x is equal to -1. The numerator will not factor. So there's no cancellation opportunities here. Therefore, both of those are non-removable discontinuities. Which means that there is vertical asymptotes at both places. Any questions on number 3? Okay. Number 4. What could we plug into t and get a division by 0 error? Well, let's just say we didn't know, and let's try to solve. T squared plus 1 cannot be 0. So we could subtract 1. So t squared cannot be -1. And so we're going to take the square root. Hopefully your eyebrows are raising a little bit. And so we have that t cannot be I. Well, what was the domain to start with? Our domain is the set of all real numbers. I was never in the domain to start with. It's like I come into my classroom at Prairieland High School and I tell a student that's at Chisholm, get out of my classroom. I can't tell him to get out of my classroom. He's not even in it to start with, you see. So we're trying to tell the I to get out of the domain, but the I never was in the domain. So there's nothing that we could plug in place of t, no real number, that we could plug in place of t and create a division by 0 error. So there's no discontinuities, which means there's no vertical asymptotes. Okay? Any questions on that? All right. Now, we're getting into a realm here that we haven't had as much experience with as far as the students I'm presently teaching, and that's getting into the graphs of trigonometric functions. But we have introduced this a little bit, and because we haven't done a whole lot of it, then what I'm going to do is we're just going to build a table. Because when we don't know how to graph something, based on experience, then all we can do is revert to a table and plug numbers in and just figure it out. So we'll do that. Now, normally when we build a table trigonometrically, and maybe I should do it like, I'll do it sideways, then normally what we do is we say, okay, we're going to take my angle measure. I'm just going to take x. And then I'm going to do tangent 2x. But the x's that we usually choose are like negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's our normal stuff that we choose when we're doing our trigonometric tables. Now, why would we be using those numbers? There are quadrantal angles, right? Quadrantal angle answers are answers like 0, 1, negative 1, undefined. Instead of square root 3 over 2, square root 2 over 2, square root 3, we don't want those kind of answers. We want pretty answers. So we use our quadrantal angles to build our graph. Plus, we're going to find our maximums and minimums in there anyway. It's going to go from a peak of positive 1 to a valley of negative 1. And so we're finding the high points and low points anyway, and then the intercepts by using our quadrantal angles. Now, the problem is here that we got 2 times that. So what we would have is tangent of negative 2 pi, you see. And this would turn into the tangent of 2 times that would be negative pi. And then here we would have tangent 0. And here we would have tangent pi. And here we would have tangent 2 pi. And here we would have tangent 3 pi. And here we would have tangent 4 pi. Which could tell us we may need some different numbers, you see, because of that 2. That 2 is messing with us, okay? But let's go ahead and graph this. Now, what I'm going to do because of that 2, and you can see that we would really like to have those half steps, but we went from 2 pi to 3 pi. This is jumping in increments of pi over 2. But because of that 2, it made me jump in increments of pi. You see what happened to us? Well, if we really want to get on our graph, if we want the y to be jumping, if we want it to end up being in half units, we need to start with force, right? Is that making sense? Okay, yes. So if I want to get those nice pictures that we're used to getting, then I need to go back and I need to start out with fourths just so I end up with halves. Okay, so let's go back to the drawing board and do that again. Just trying to think our way through it. You haven't had some trigonometry experience, and so we're having to work from what we know. Okay, so we're going to go back then, and we're going to think about having negative pi over 2 negative pi over 4, 0 pi over 4 pi over 2, 3 pi over 4, and pi. Because it's being doubled, we wanted to end up with steps of pi over 2, and because it was doubled, that wasn't going to happen, okay? So, now, we had tangent to pi, 2x, excuse me. So now this is going to become, I'm going to leave the tangent off just so you can see. This is going to become tangent of what? I'm just going to put t because I don't have space. Tangent of, but it's going to be negative pi, right? Tangent of negative pi. And then we're going to have the tangent of negative pi over 2. And then we're going to have the tangent of 0. And then we're going to have the tangent of pi over 2. And then we're going to have the tangent of pi. And then we're going to have the tangent of 3 pi over 2. And then we're going to have the tangent of 2 pi. Okay, now we got some numbers we can deal with. Let's get the answers for that. I'll just make a third little piece here. That's not easy to do. When it's all in the wrong place, I had to get my amount off right and miss it exactly every time so I could hit the right spot. Didn't do too bad. Okay, so what is the tangent? Let's start with tangent 0. What's the tangent of 0? 0. What's the tangent of pi over 2? Undefined. What is the tangent of pi? 0. 3 pi over 2, undefined. 2 pi, 0. Negative pi over 2, undefined. Negative pi, 0. Okay. Now, let's grid this out. Sorry. Negative pi over 4. Okay, I'm going to try that again. I've got to adjust my mind. My board got off fast there. Okay. Getting off way over here. So negative pi over 2, negative pi over 4, pi over 2, pi over 4, pi over 2, 3 pi over 4, and pi. Now, these are these x's that we had to choose to get the other ones, but we're graphing from these original x's to these y's right here, right? Okay, so at x is negative pi over 2, what was the result at negative pi over 2? 0. So I've got a crossing of the axis right there. Okay, what's happening at negative pi over 4? Undefined, so vertical asymptote. What's happening at 0? 0, pi over 4, and then 0, vertical asymptote, 0, vertical asymptote, and we could continue. Now, if we were to go the other way to negative 3 pi over 4, we would have another vertical asymptote. Okay. Now, the question is, where's there a vertical asymptote? And the answer is there's an infinite number of them. So how do we mathematically represent all of those? Well, here's what I do in trigonometry. I will say first time, this is like what I like to write down, first time, next time, all the time. First time plus the next time times all the time. Okay? That may look goofy, but you'll understand. When I tell you what I'm talking about, you'll understand. And I really should say it like this. Let me do a better job. Let's say distance to next time. That's better. Distance to next time. So we want the first time, the distance to the next time, and then all the time. Okay. So, when is the first time in the positive realm that we see an asymptote? Pi over 4. Now, how far is it to the next asymptote? Well, it's from here to here. So from pi over 4 to 3 pi over 4 is 2 pi over 4, which is pi over 2. So the distance to the next time is pi over 2. So I found the first time. I found the distance that it takes me to get to it the next time, the next time, the next time. But then how do I say, well, then all the time? Well, I'm going to add an integer number of those pi over 2's. That gets me all the time, you see. Now, the integer allows me to be over here on this negative side also, right? By putting an n. If I put a k like would represent a positive integer, it'd only leave me on the positive side. So we got the first time. We got the distance to the next time. And by multiplying that distance by n, we get all the time. So there's the set of all vertical asymptotes for the equation f of x equal tangent to x. Okay? Any questions on that? Wow, that was a lot of stuff. Fun. Okay. Now, the next question is, how do I get my board to work? Hit it in the right spot. I'm going to pause. Okay, we paused for just a second to realign the board. It was getting a little challenging to make it right where I needed it to. Number 6, determine whether the graph of the function has vertical asymptotes or a removable discontinuity at x equal -1. Okay? Now, if we can remove the discontinuity, then there's not going to be an asymptote there. So we would factor. What will the numerator factor into? X plus 1 times x minus 1. The difference between two squares factors into binomial conjugates. We know that because of this denominator, we would have at x equal -1 a discontinuity, right? And we want to know if it's removable or not. If it's removable, then we're going to call it a removable discontinuity. If we can't remove it by factoring, we're going to say, well, there's an asymptote there because we could not get rid of that error. Well, once we factor, we see that the x plus 1 factors cancel. So we have created a g function equivalent to the f function in all points but 1. Therefore, we have removed the discontinuity by factoring. So it is a removable discontinuity at x equal negative 1. Any questions on number 6? Okay. When we look at number 7, x squared plus 1 in the numerator will not factor. So at x equal negative 1, which is what would produce a division by zero error in this, we have a discontinuity. We were not able to remove it through factoring or manipulation, therefore we say that the discontinuity is non-removable. Which tells us then that there must be a vertical asymptote. At x equal negative 1. Any questions on that? Do we recall what kind of an other asymptote would it have? Does it have a horizontal asymptote? To have a horizontal asymptote, the degree of the numerator and denominator would have to be the same, or the degree of the denominator would have to be less than the degree of the numerator. If the degree of the numerator is larger, then there is no horizontal asymptote. But because the degree of the numerator is 1 larger, then there would be a slant asymptote. And the equation of that slant asymptote would be the result of dividing those two things, right? And eliminating the denominator. So we know there's a vertical asymptote because the degree of the numerator is larger than the degree of the denominator. We know that there is no horizontal asymptote. We know that because the degree of the numerator is 1 more than the degree of the denominator, then there's a slant asymptote, which we could find by dividing numerator by denominator and eliminating the remainder. All right, any questions through number 7? Appreciate your attention.